Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2023 chemistry exam in the Northern Hemisphere. We will focus on multiple choice questions related to electrochemistry. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Primary cells are disposable and designed not to be recharged. Fuel cells are constructed in which the reactants are supplied continuously, allowing constant production of electrical energy. Secondary cells are rechargeable and designed to be reused many times. In a secondary cell, chemical energy is transformed into electrical energy during discharge and electrical energy is transformed into chemical energy during recharging. So, D is the correct answer. Side reactions occur in any cells. Fuel cells are not a type of secondary cell because they cannot be recharged. Cathodes are the electrodes where reductions occur, not always positively charged. Make a cell that produces 1.5 volt. From the data book, we know that Cr2O72 and Cr3+ construct the cathode, and Sn2+ and Sn construct the anode. The EMF between is 1.5 volt equals 1.36 minus 0.14. So, the correct answer is D. Half cell 1 is hydrogen peroxide plus PT electrode and half cell 2 is nickel nitrate plus nickel metal. PT electrode does not take part in reaction because PT is an inertial metal. The standard electrode potential of hydrogen peroxide is higher than that of nickel ions, so hydrogen peroxide gains electrons from nickel metal. In this cell, hydrogen peroxide oxidizes and nickel metal reduces the agent. This question assesses the difference between secondary cells and fuel cells. Secondary cells and fuel cells are the main targets of VCE examination. Both secondary cells and fuel cells require reactants, half cells, to be separated and connected via an external circuit. Both also require reactants. The anode is the electrode that loses electrons, and the cathode is the electrode that gains electrons. Negative electrodes of fuel cells always lose electrons, and negative electrodes of fuel cells are always anode. When the secondary cell is recharged, its negative electrode gains electrons. When the secondary cell is discharged, its negative electrode loses electrons. So, the anode in a secondary cell is negative during discharge but positive during recharge. So, the number 3 statement is not suitable for the secondary cell but is right for the fuel cell. In this electrolysis cell, there are 3 components: potassium chloride, potassium bromide, and water. Graphite is an inertial electrode and does not take part in the reaction. Both potassium chloride and potassium bromide are dilute solutions. So, the standard electrode potential is suitable for this question. From the data book, we know that chlorine and bromine solution is a stronger oxidizing agent than water and potassium ions. But there are no chlorine and bromine solutions in this cell. Chlorine is not equal to chloride ions, and bromine is not equal to bromide ions. Water is a stronger oxidizing agent than potassium ions. So, water is the strongest oxidizing agent in the cathode. Water gains electrons and hydrogen bubbles appear in the cathode. In the anode, there are 3 components: chloride ion, water, and bromide ion. Bromide ion is the strongest reducing agent. So, the bromide ion loses electrons and the solution becomes brown because bromine is brown in color. So, the D is the correct answer. Electrolysis of concentrated sodium chloride solution produces sodium hydroxide in the cathode. The reaction in the cathode is electrolyzing water. 1 mole of electrons is equivalent to 1 mole sodium hydroxide. According to Faraday's rule, we calculate out the amount of charge required. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Chemistry channel.